Okay guys, today what we're going to do is we're going to start chapter 5. Now chapter 5 is called Pythagoras Theorem. Okay, so we're going to be learning about Pythagoras Theorem. Now Pythagoras was a Greek guy. Okay, he was a philosopher, a Greek philosopher, and he was around 500 years before modern time. Okay, so he was around roughly 2,500 years ago. Okay, and that's when he came up with this theorem. Now, it's debatable whether Pythagoras was the first person who came up with it. They say that that this theorem was already in use well before Pythagoras' time, but he was the one who has been formally accredited with coming up with this theorem. Okay, now, when we look at Pythagoras' theorem, okay, firstly I want to talk about what it is related to. Okay, so Pythagoras' theorem is based on right-angled triangles. Now, you guys have done triangles in the past. You've worked with triangles plenty of times in the past. Okay, and now we're going to start looking specifically at right-angled triangles. So I want to start firstly by just looking at the shape of a right-angled triangle, what we know about it, and also we're going to name some sides in it. Okay, so firstly, Pythagoras theorem works with right-angled triangles. Okay, so that's what we're going to be looking at today. Now, that means that if you want to apply Pythagoras' theorem, you must have a right-angled triangle. And you must know that it is a right-angled triangle. Okay, there must be evidence in your questions that it is a right-angled triangle. Okay, you cannot use Pythagoras' theorem, at least in year 2, without knowing that is definitely a right-angled triangle. Okay, so there must be some information in your picture to say that it's right angle, or it must be very clear. So for example, you must know that one of the angles is 90 degrees. Okay, so a right-angled triangle we know looks something like this. Okay, this is a right-angled triangle. Okay, and we have always a little box in the corner here to show that it's 90 degrees, to show that it's a right angle. Okay, now we're going to ignore a little bit about what the textbook uses, okay, because the textbook calls 2 of the sides legs. We're not going to call them legs. That's a little bit strange. We're just going to call them sides. So this is just one side, and this is another side. Okay, and you'll notice I labeled the 2 sides that are next to the right angle. Okay, so these 2 sides are next to the right angle. Okay, we're just calling them sides. Now, this other side, the one that is opposite the right angle, okay, this has a special name. Okay, so we call this the hypotenuse. Okay, so this is the hypotenuse. Okay, now the hypotenuse has a few properties. Firstly, as we said, it is opposite the right angle. That is the first property of a hypotenuse. And the second property is that it is always the longest side. Okay, and that makes sense because that 90-degree angle that we have down here is directly opposite the hypotenuse. So it's opening the triangle up as far as it possibly can. Okay, that makes the side longer. All right, so as I said, Pythagoras' theorem works with these right-angled triangles. Now today what we're going to do is we're going to look at what the theorem is. We're not going to do it with any numbers today though. We're going to do one example where I show you with numbers how it works. But today, all I want you doing is getting familiar with the sides of the triangle and naming the theorem, okay? So with triangles and with shapes in general and with lines, with everything, we have said in the past that if you have a point or a corner, we label it with a capital letter. If we have a side or a line, we label it with a lowercase letter. That's really important in this unit, okay? It's really important that you guys are using the correct notation. We want you to get this right for the future. So please make sure you're careful about whether you're using lowercase or uppercase, whether you're using capital letters or small letters when you're doing this, okay? Now, the 90-degree angle should be always called a C, okay? So the 90-degree angle will always be C. Okay, in a right angled triangle, the other two letters will be A. Oops, I'm not sure why this is being silly today. The other two letters are going to be A and B. All right, and you'll see, as I said, I've labeled them with uppercase. They're labeled with capital letters because they are points. All right, what that means is that the hypotenuse is always going to be a little c, because you'll remember we name the sides by the letter that is opposite it at the angle. Okay, so the side C is opposite angle C. Side B is going to be opposite angle B. Okay, so this is going to be side B, and again lowercase, not uppercase. All right, side A is going to be opposite angle A, so this is going to be side A. All right. Oops. Okay, and this is how we label our right angle triangle. All right. Now, Pythagoras' theorem. We're going to come up with a formula in a sec, so we're going to write it with a formula, but firstly I want to actually show you how this works. Okay, so this might be a little bit tricky for me. I'm going to draw a triangle here. So we're going to have 4 centimeters here, 3 centimeters here, and then this line up here. Okay, so you can see that one of my sides is 4 centimeters, one of my sides is 3 centimeters, and if you measure the other one, you'll actually see that, well, we'll work out what it is. Okay, what we're going to do is we are going to draw a square coming off the side of this one, like this. Okay, that's a 4 by 4 square. We're going to draw another square coming off the side of this one. Okay, and that's a 3 by 3 square. All right, and then we're going to draw another square coming up here, and I hope this works. Now that looks close enough to being a square. Okay. All right, it's on a bit of a strange angle, but fine. Okay, so this is our right angle. We have our two sides. Can I turn this? No. Okay, let's just pretend we got that right. Okay, we have our two sides and we have our hypotenuse. All right. Now, the area of this green square here. Okay, if we measure it, we've got 4 times 4. So this area here is going to be 16. It's going to be hard to read if I do it like that. It's going to be 16 centimeters squared. Okay, this blue square is going to be 3 by 3, which gives us 9 centimeters squared. Now, if we actually measure this red square, what we actually get is this side that runs along the hypotenuse, and therefore the other sides of the square also, are actually 5 centimeters. Okay, and this will give us a square of 25 centimeters squared. Okay, now what you can actually see is that there's actually a relationship between these, because 9 plus 16 is equal to 25. Okay, now this is Pythagoras' theorem. Okay, we have a squared plus b squared is equal to c squared. All right, this is Pythagoras' theorem. So if you square side A and then you square side B and you add them together, they will add up to that hypotenuse squared. Okay? Now, as I said, to start off with, we're not actually going to be doing anything with numbers. All I want you doing is just identifying the Pythagoras' theorem in various triangles. Okay, so you're not always going to get A, B, and C as the letters. Okay, we do try and use them as much as possible, but you are also going to get other letters. Okay, so for example, if we have a triangle like this, okay, and we're going to call this side P, Q, and R. All right, then I want you to think about how this triangle will be labeled and therefore what its Pythagoras theorem would be. So this side over here, side RQ, what is it in the case of this triangle? Well, RQ is opposite side P. Okay, so it's going to be opposite angle P, sorry, so it's going to be side P. Okay, side PQ, remember that is the hypotenuse. We're going to write it on there. This is the hypotenuse. Okay, you can see it's the longest side. You can see also that it's opposite the right angle. It's opposite angle R, so it's side R. And the other short side, okay, is opposite angle Q, so it's going to be side Q. So if we're going to write Pythagoras' theorem for this triangle, then we know that our short sides are Q and P. So for this triangle, we have Q squared plus P squared equals, and the hypotenuse squared, so R squared. All right, and this is it. This is all I want you guys doing today, is just getting used to which side is which, okay, and writing the theorem using those sides. Okay, so I'll put some questions on the classroom for you. I don't like the way that the textbook has done this first section. You can have a look at it. If you want to do those questions, you can from 5.1, but I'm happy if you just do the questions that I upload to the classroom for you for today. It's just two very nice short ones just to get you used to looking at this, okay? So please make sure you always know which side the hypotenuse is. I do suggest you label it, okay? And then write down what the theorem is, okay? And that's that.